grams of food a day. That's over 365 kilograms a year per person, and more than 28,800 kilograms over the course of a lifetime. And every last scrap makes its way through the digestive system. Comprised of 10 organs, covering 9 meters, and containing over 20 specialized cell types, this is one of the most diverse and complicated systems in the human body. Its parts continuously work in unison to fulfill a singular task, transforming the raw materials of your food into the nutrients and energy that keep you alive. Spanning the entire length of your torso, the digestive system has 4 main components. First, there's the gastrointestinal tract, a twisting channel that transports your food and has an internal surface area of between 30 and 40 square meters, enough to cover half a badminton court. Second, there's the pancreas, gallbladder, and liver, a trio of organs that break down food using an array of special juices. Third, the body's enzymes, hormones, nerves, and blood all work together to break down food, modulate the digestive process, and deliver its final products. Finally, there's the mesentery, a large stretch of tissue that supports and positions all your digestive organs in the abdomen, enabling them to do their jobs. The digestive process begins before food even hits your tongue. Anticipating a tasty morsel, glands in your mouth start to pump out saliva. We produce about 1.5 liters of this liquid each day. Once inside your mouth, chewing combines with the sloshing saliva to turn food into a moist lump called the bolus. Enzymes present in the saliva break down any starch. Then your food finds itself at the rim of a 25-centimeter long tube called the esophagus, down which it must plunge to reach the stomach. Nerves in the surrounding esophageal tissue sense the bolus's presence and trigger peristalsis, a series of defined muscular contractions. That propels the food into the stomach, where it's left at the mercy of the muscular stomach walls, which pound the bolus, breaking it into chunks. Hormones secreted by cells in the lining trigger the release of acids and enzyme-rich juices from the stomach wall that start to dissolve the food and break down its proteins. These hormones also alert the pancreas, liver, and gallbladder to produce digestive juices and transfer bile, a yellowish-green liquid that digests fat, in preparation for the next stage. After 3 hours inside the stomach, the once shapely bolus is now a frothy liquid called chyme, and it's ready to move into the small intestine. The liver sends bile to the gallbladder, which secretes it into the first portion of the small intestine, called the duodenum. Here, it dissolves the fats floating in the slurry of chyme so they can be easily digested by the pancreatic and intestinal juices that have leached onto the scene. These enzyme-rich juices break the fat molecules down into fatty acids and glycerol for easier absorption into the body. The enzymes also carry out the final deconstruction of proteins into amino acids and carbohydrates into glucose. This happens in the small intestine's lower regions, the jejunum and ileum, which are coated in millions of tiny projections called villi. These create a huge surface area to maximize molecule absorption and transference into the bloodstream. The blood takes them on the final leg of their journey to feed the body's organs and tissues. But it's not over quite yet. Leftover fiber, water, and dead cells sloughed off during digestion make it into the large intestine, also known as the colon. The body drains out most of the remaining fluid through the intestinal wall. What's left is a soft mass called stool. The colon squeezes this byproduct into a pouch called the rectum, where nerves sense it expanding and tell the body when it's time to expel the waste. The byproducts of digestion exit through the anus, and the food's long journey, typically lasting between 30 and 40 hours, is finally complete. TED-Ed is a nonprofit. If you value our work, please consider supporting it.
I hope you found that little video helpful in further explaining the digestive system. There's some definitely more facts that go in a little more in depth than we really need to know, but just a fun way to see it presented. So next, looking at macronutrients. These are the 3 main nutrient components of our diets: carbohydrates, proteins, and fat. For diabetes, we are primarily focused on carbohydrates to determine and adjust insulin, since carbohydrates break down into sugars and are most quickly absorbed into your bloodstream. To further explain this, I have found another great video to clarify and provides a visual demonstration of how carbohydrates break down and act in the body. This video is again a little more in depth, discussing some more complex topics. So don't get bogged down in the details. We'll walk through the most important components later as they pertain to the next topic.
Which of these has the least carbohydrates? This roll of bread, this bowl of rice, or this can of soda? It's a trick question. Although they may differ in fats, vitamins, and other nutritional content, when it comes to carbs, they're pretty much the same. So what exactly does that mean for your diet? First of all, carbohydrate is the nutritional category for sugars and molecules that your body breaks down to make sugars. Carbohydrates can be simple or complex depending on their structure. This is a simple sugar, or monosaccharide. Glucose, fructose, and galactose are all simple sugars. Link two of them together and you've got a disaccharide, lactose, maltose, or sucrose. Complex carbohydrates, on the other hand, have three or more simple sugars strung together. Complex carbohydrates with 3 to 10 linked sugars are oligosaccharides. Those with more than 10 are polysaccharides. During digestion, your body breaks down those complex carbohydrates into their monosaccharide building blocks, which your cells can use for energy. So when you eat any carbohydrate-rich food, the sugar level in your blood, normally about a teaspoon, goes up, but your digestive tract doesn't respond to all carbohydrates the same. Consider starch and fiber, both polysaccharides, both derived from plants, both composed of hundreds to thousands of monosaccharides joined together, but they're joined together differently, and that changes the effect they have on your body. In starches, which plants mostly store for energy in roots and seeds, glucose molecules are joined together by alpha linkages, most of which can be easily cleaved by enzymes in your digestive tract. But in fiber, the bonds between monosaccharide molecules are beta bonds, which your body can't break down. Fiber can also trap some starches, preventing them from being cleaved, resulting in something called resistant starch. So foods high in starch, like crackers and white bread, are digested easily, quickly releasing a whole bunch of glucose into your blood, exactly what would happen if you drank something high in glucose, like soda. These foods have a high glycemic index, the amount that a particular food raises the sugar level in your blood. Soda and white bread have a similar glycemic index because they have a similar effect on your blood sugar. But when you eat foods high in fiber, like vegetables, fruits, and whole grains, those indigestible beta bonds slow the release of glucose into the blood. Those foods have a lower glycemic index, and foods like eggs, cheese, and meats have the lowest glycemic index. When sugar moves from the digestive tract to the bloodstream, your body kicks into action to transfer it into your tissues, where it can be processed and used for energy. Insulin, a hormone synthesized in the pancreas, is one of the body's main tools for sugar management. When you eat and your blood sugar rises, insulin is secreted into the blood. It prompts your muscle and fat cells to let glucose in and jumpstarts the conversion of sugar to energy. The degree to which a unit of insulin lowers the blood sugar helps us understand something called insulin sensitivity. The more a given unit of insulin lowers blood sugar, the more sensitive you are to insulin. If insulin sensitivity goes down, that's known as insulin resistance. The pancreas still sends out insulin, but cells, especially muscle cells, are less and less responsive to it. So blood sugar fails to decrease, and blood insulin continues to rise. Chronically consuming a lot of carbohydrates may lead to insulin resistance, and many scientists believe that insulin resistance leads to a serious condition called metabolic syndrome. That involves a constellation of symptoms, including high blood sugar, increased waist circumference, and high blood pressure. It increases the risk of developing conditions like cardiovascular disease and type 2 diabetes. And its prevalence is rapidly increasing all over the world. As much as 32% of the population in the US has metabolic syndrome. So let's get back to your diet. Whether your food tastes sweet or not, sugar is sugar, and too many carbs can be a problem. So maybe you'll want to take a pass on that pasta, sushi roll, pita burrito, donut burger sandwich.